Hi everyone, I'm Aji Setiawan as presenter in this project. Let me tell you a few information. I'm currently majoring in Naval Architecture and Marine Engineering in Diponegoro University, Indonesia. Mr. Samuel, Mr. Hadi, and Mr. Palin are as well, while Mr. Iqbal Ivo from Strathclyde National University for Glasgow with Naval Architecture and Marine Engineering. I think my introduction is enough. Let's move to my presentation. The title is Study of Middle Interceptor Implementation on Patrol Boat. What is interceptor? Interceptor is thin plate extension of a ship hull. Interceptor usually installed on transom, midship, in between midship and transom. Interceptor installation depend on ship loads, center of gravity of the ship, and ship trim. Next, this picture is shown the interceptor that installation of the ship transom. The purpose of this interceptor is reduce the trim angle. Next, this picture is shown the interceptor configuration in the bow and the stern of the ship. Stern interceptor provide lift force on the transom, thus reduce the trim angle and weighted surface area of the ship. How does this happen? Reduced trim value is caused by lift force in the stern part of the ship, creating moment force toward LCG. Therefore, to reduce the weighted surface area and trim angle. The aim of the study is to study interceptor effect toward the resistance value of the patrol boat by using numerical approach. The addition of the interceptor is expected to control the trim angle so that it will reduce the total drag of the ship. Interceptor will be installed in varied angle and position, aiming to obtain information about the interceptor mechanism and its effect on resistance, trim, and sinkage. Next is method hull form characteristic patrol boat. This is a main dimension on patrol boat, and this picture is show the body plan of the patrol boat. Next is middle interceptor placement configuration. During this study, we use 3 position variation of the interceptor and 2 angle position. The totaling is 6 model variation. The placement of the interceptor is shown in this picture. The next is numerical implementation. Overgrid method will be used during numerical implementation, where there are 2 geometries. There are background geometries as the cell donor and offset as the cell acceptor. Virtual towing tank used for this study is shown in this picture, with L as ship length, H as ship height, and B as ship bridge. Towing tank dimension is based on ITTC recommendation. We also use 2 degrees of freedom. They are pitching or y-axis rolling and heaving that axis translation. E plus value is also based on ITTC recommendation. The time step is current Predict-Levy method is used to determine the time step used for the simulation. Time step value will be lower as the ship reaches higher speed. The time step used for this study is 0.006 based on ITTC recommendation 2. The next is mass density. Mass are concentrated on water surface area around the ship hull. This will result in lower competition time. The denser the mass density is, the more time needed for the simulation. Hence, the mass are concentrated on curtain part. This result in discussion. Total drag verification. Verification is carried out to minimize error during simulation, where the chart depicts the difference between software star CCM and compared to Savitsky equation. Simulations are carried out with 1 million until 1,200,000 cell number. Concentrate on water surface area around the hull. As we see in the chart, to FR 0.33 and 0.66 shown similar result of total drag, while FR 1.0 to 1.3 shown slight difference. This picture is the trim and sinkage result. The first chart is show comparison of trim angle based on ship speed or float number. A float number less than 1.33 shown increment in the trim value compared to that of bare hull. Interceptor installation on 4-meter interceptor installed behind midship on the butt angle 80 degree and 90 degree show trim reduce compared to that the bare hull. And the second chart is shin kick value of every model either 80 degree or 90 degree is shows increment compared to bare hull shin kick value. And then resistance result. Chart A depicts total drag comparison, which show the Interceptor 10 in increased total drag value compared to bare hull drag total. Total drag value of 4-meter behind midship model is lower than of midship Interceptor model. Generally, Interceptor installed in 80 degree has lower drag value compared to that 90 degree. 4-meter behind midship Interceptor model with 80 degree shows the most optimal drag value. In star CCM, drag total is composite two components. They are a pressure drag as the peak B and shear drag as the peak C. This is a resistance of the model by Seok. Middle interceptor will have a significant influence on ship momentum to lift force in the bow. Interceptor placement near LCG will also produce higher momentum force. Thus, weighted surface area is higher as the trim increase. As in the study conducted by Seok, where total drag is increased to the ship, weighted surface area value is higher. And then is pressure distribution. Show the pressure with interceptor and without interceptor. Ship without interceptor show that pressure is mostly located the middle interceptor of the ship. Distribute in the whole area of the bottom. While middle interceptor model show that their high intensity pressure area is front of interceptor, while the other area show less pressure distribution. This comparison of drag component trim WSA of bare hull and model interceptor A. I show the component comparison of bare hull and model A, which a higher total drag compared to bare hull because weighted surface area on the model A is higher than bare hull in weighted surface area. Interceptor installed in midship will cause momentum force in the bow area of the ship. Hence, the higher trim that will cause higher trim value. Is the conclusion. Middle interceptor tend to increase the total drag of the ship. The total drag value of the interceptor model installation 4-meter behind midship show remarkable resistance result compared to the interceptor model analysis in the study. The point 2 is it's very likely because a higher momentum force followed by higher trim angle. Therefore, weighted surface area value of the middle interceptor model is higher than the bare hull. Point 3 is installation on the middle interceptor can result in higher trim and shin kick value because a further away LCG point will cause higher momentum force of the bow and increase the ship weighted surface area, resulting in the higher total drag. Thank you and have a nice day.